Good morning. Let's first recall and review what we talked about in the last class. Do you remember any topics, buzzwords, ideas? Tax. Very good. Tax and, did you say?
Subsidy.
Subsidy. Okay. So what did we learn about tax and subsidy? Do you remember anything that we talked about, that we learned from that experience?
In order to subsidize one thing,
Sit very loud.
In order to subsidize one thing, you have to tax another group.
Absolutely. So we decided to connect tax and subsidy. By the way, what is tax? What is subsidy? I mean, if you had to describe to someone who has no idea what it is you're talking about, what's the easiest way to explain what a tax is?
Revenue for,
For who?
it's like what the subsidy is, I don't know.
Uncle Sam,
How do you explain
right?
it? Huh?
Tax is a revenue for Uncle Sam, right?
Yeah,
Which is the
government.
There you go. So yeah, it's a source of the revenue for the government. Where does government, or who does the government collect the revenue from?
People and
People, businesses, exactly. Taxpayers, right? So yeah, tax is a transfer of money from taxpayers to the government, right? It can be done in all kinds of ways, proportionally to your income, proportionally to your purchases, or any other way, right? Based on the value of your house, and so on and so forth. That's a tax. What's a subsidy?
It's like almost like a discount, basically, on whatever goods you're looking for, depending on the area you live.
You're absolutely right. There is a simpler way, perhaps the simplest way to put the subsidies. It's the opposite of tax, right?
Okay.
It's a negative tax. In other words, it's a transfer of money from the government to people based on something, again, right? And again, there are various ways to subsidize businesses, subsidize consumers. And in our exploration of properties and impacts of tax and subsidy in the last class, we picked one particular type of tax, one particular type of subsidy. What do we call it? What adjective did we use? Specific, absolutely. Specific tax, specific subsidy. So what is a specific tax? What kind of a tax is it?
Tax pertaining to a certain item.
Certain item, definitely. And how is the tax set or
fixed.
set up?
It's a fixed amount.
It's a fixed amount in dollars, right? Some people might say also sales tax is fixed at 7%, but it's proportional in percentage terms, whereas specific tax is in dollar terms, right? We chose to study the properties and impact of the specific tax, which is specified in terms of dollars per unit of a good. Why that one? Do you remember why I decided that that's what we're gonna do as opposed to proportional tax, such as sales tax? Why that one, not something else? Guys, what we did in the last class, it was kind of long, it was boring, but did it strike you as rocket science? That's why we chose specific tax, because it's simple, right? It's easy to study. So that's the only reason, really. The fact, though, is if we chose some other types of taxes, we would certainly learn very similar lessons. The takeaways would be very similar. So this way we actually gained all that insight, and we saw how taxes and subsidies affect markets. We found out at the lowest possible cost, right? At the lowest possible exertion of effort. Because we did it in the simplest possible way using the specific tax. Very good. Now, we studied both tax and we studied subsidy. And predictably, the effects of tax and subsidy are kind of mirror images of each other, right? They work in opposite ways. Why did we study both of them? Why didn't I just show you tax and tell you there is such a thing called subsidy, it's the opposite of tax? Sit very loud.
So we can see how it works.
Well, I would tell you, it works exactly opposite way. Yes?
Because it's a certain amount you take from the tax revenue to implement towards a subsidy.
First of all, yes. In other words, we implemented the analysis of tax and subsidy as a part of one integrated policy, tax subsidy scheme, right? Where we showed how a government that wants to keep its books balanced has to generate revenue in order to implement the new subsidy program, right? So that was one practical reason. Of course, second very important reason, more conceptual and more, I don't know, strategic, I don't know, reason why we implement or we studied both is the fact that subsidy really does work in the opposite direction from tax in all respects, except one. Where is the subsidy not a mirror image of the tax? What do all policies have in common? Floors, ceilings, supports, tax, subsidy, everything you've seen so far results in one predictable impact. Guys, what is this course all about? Yes?
It decreases.
Decreases what? Yeah, that one. What do we call it? Total surplus, right? Total surplus. All policies we've studied so far decrease total surplus. What does that tell you about efficiency?
Decreases.
All of those policies tend to decrease efficiency of the market. Exactly. That's what we learned. So, yes, tax and subsidy are sort of like mirror images of each other, where one goes down, the other one goes up. And it holds for all the variables we studied, quantities, prices, right? Consumer surplus, producer surplus, but not total surplus. Total surplus in both cases goes down as a result of the policy. That makes sense? Very good. Why is that important? Why is that a worthy result to go after? Because that's what this entire course is about. It's about efficiency, right? We're trying to gain insight into efficiency. Do you remember why efficiency is important? Why efficiency is actually why efficiency is the focus of our study? Because if you studied economics in an inefficient country, it would be just as boring as here, only you would be sitting in a ramshackle building with no AC, and you would have very little career to look forward to, and not much of an American dream at all, right, to chase after. So that's the difference. It's all about efficiency. Basically, the difference between awesome countries that are great to live in and countries that are not great to live in is efficiency first and foremost. Okay? So that's why it's all about efficiency. And yes, we studied also tax and subsidy to see how they affect the market, and we also showed that they also reduce efficiency. Very good, guys, we're done. We wrapped up study of policies. Now, when I finally get to update the Blackboard, I will post the corresponding homework where you will be practicing tax and subsidy, okay? And like I mentioned, I'll post the videos, so it's all gonna be there. Now, at the end of the last class, I introduced that last concept that we need to implement to understand the economic incidence of tax and subsidy. In other words, how consumers or how the burden of the tax affects or splits between consumers and producers. How the benefit of the subsidy is shared by consumers and producers. Who is hurt more, who benefits more. And at the end of the last class, we developed a somewhat intuitive understanding of that all-important property of supply and demand. What's the difference between the two demand curves you're looking at? One looks kind of flatter, the other one looks kind of steeper.
Consumers get hurt. It's the elasticity.
Elasticity, right? Absolutely. And depending on just how elastic or inelastic demand is, tax will disproportionately hurt consumers or producers, right? Depending on relative elasticities of supply and demand. So that's how we motivated our study of supply and demand, of elasticity in the last class. Now, we talked about elasticity. I asked you about perfectly inelastic demand, perfectly elastic demand, and we came up with some examples, some of which are more meaningful and well intuitive, and others were kind of strange, but still we found some examples for various elasticities of demand, right? Similar examples, of course, can be pointed to when it comes to supply. You can also have supply of some goods that is relatively more elastic, supply of other things that's relatively less elastic, just to jumpstart that intuition again. We haven't talked about elasticity of supply in the last class, but let me ask you, what do you think perfectly inelastic supply would look like?
Demand straight up and down.
Demand was straight up and down. That was perfectly inelastic demand, correct? Perfectly inelastic demand. What does a perfectly inelastic supply look like? It's perfectly inelastic supply. Okay? As you said, straight up and down. In other words, vertical straight line, right? I'm not sure it doesn't really look vertical. Let me make it look vertical. Okay? That would be perfectly inelastic supply. In other words, a supply where firms are willing and able to produce a certain quantity at a certain price. Firms are producers or suppliers, right? On the other hand, when the price rises, suppliers, producers, firms are not willing to produce anymore. What do you think? Can you think of some example of a market where supply would be perfectly inelastic? No matter how high the price goes, no more units will be supplied. It's weird, right? Well, there is a market like that. I'll give you an example. It's a typical example, and I'm not sure I can think of any other example than that. Let's say a wealthy collector is selling off Van Gogh sunflowers. There's one picture like that in the world, right? It's being auctioned at Sotheby's of London, okay? And the bidding starts at measly 50 million. And after a couple hours of bidding, the price climbs to 150 million. Price climbs significantly. Does it mean there's suddenly 2 Van Gogh sunflowers being supplied? There you go. Okay? So, typical example of markets with perfectly inelastic supply are rare pieces of art, collectibles, that sort of stuff, right?
Could it be the housing market too?
Hmm.
It's only one house.
Yeah, that's what I was thinking. Maybe like a private island.
Well, if you have multiple bidders.
I see what you're saying. In other words, you're talking about supply of your house. In other words, you put your house on the market, And just because people start bidding over your house doesn't mean there's gonna be more houses standing on your lot on top of each other, right?
It's just like the people that want the Van Gogh. Like certain people want just that. If you're selling your house, certain
Absolutely.
people just want your
I
house.
like that idea. I like that idea. It's very creative. This is awesome, guys. This is like a second half of semester. You all are pretty tired, and you can still come up with creative ideas. I like that. Why doesn't it normally pop up? Why does an example like you're suggesting normally pop up when people think of market elasticity of supply? Because when we think of a market, housing market, we usually don't think of your house. We mean houses in Jacksonville, for example, or houses in the South Side, right? Rarely do we think of one house as its own market. Now, could you do that? Sure, just as you can think, as you pointed out, about one Van Gogh picture, right? You could make a point that there exists a market with fine paintings, right? And in that market, as the prices rise, more and more paintings will be sold, right? Will be auctioned off. So that's an interesting way to look at it. Of course, when you're talking about a house, you might, I don't know, you might raise an example of a castle, right? There's a certain castle somewhere, and once it's on sale, it's only one like that.
Well, there's more than one fine painting though, too.
Oh, exactly.
Yeah.
And there's more than one castle. Yeah. So again, it very much depends on how it's specified. I like that example. Very good. So, again, even supply, just like demand, varies in elasticity among various markets. What we're going to do today is introduce a way to measure elasticity. We will do it through a very brief, simple numerical calculation, along which we learn the way to calculate elasticity, the pitfalls of measuring elasticity, and ultimately we will fix any possible bugs that will pop up, and we'll come up with an exceedingly simple formula for calculating elasticity. And that's the formula you will then use from now on the homework, on the midterm, on the final, to calculate elasticity. You plug the numbers in, the formula spits out the number, and you're done. Okay? So, let's use our good old workhorse demand defined by P equals 10 minus Q. Okay? Now let's consider elasticity along this demand curve, corresponding to a segment of a demand curve defined by two pairs of prices and quantities. Suppose price in this market is $8. What would be quantity demanded?
2.
2. Very good. Suppose that price falls down to $6. What will happen to quantity demanded?
No, raise 2.
Increases by 2 from 2 to 4, right? Very good. And so we see that in this market, predictably, when price falls from 8 to 6, quantity demanded increases from 2 to 4. On the other hand, if the price increases from 6 to 8, quantity demanded falls from 4 to 2. That makes sense? Very good. Do you remember what elasticity actually is? What is elasticity? I mean, we drew elastic, inelastic, perfectly inelastic, but that's not about drawing. What did we mean by elasticity?
When the price like of a good or something goes
When
up,
the price of a good or service changes,
like customers' reactions are big.
consumers respond, right? And sometimes they barely respond, and sometimes they overreact, you could say, right? Response is overwhelming. So basically we're measuring consumers' response to change in price. So what would you say, how big is the response of consumers here? Big or small? You're saying big. Price goes, let's say, from 6 to 8, and consumers' quantity demanded falls from 4 to 2 by 2 units. Why are you saying it's a big response?
Oh, I thought you meant, well, I was just saying, like, when it was $6, it was a big response, now that it's gone up 8, now only like 2 people.
So is it a big response or not such a big response? Maybe not such a big response. Okay, guys, let me tell you right away. We will not measure elasticity in terms of units, change in units of good buyers are willing and able to buy. We will not measure response in terms of price in changes in price in dollars. Why not? Let's say you have your favorite energy bar. It sells for $2. You've been buying it forever. You rely on it. It's your favorite comfort. Suddenly the price goes up from $2 to $2.50. And you're like, oh, this is so outrageous. There's plenty of energy bars. All of them sell for $2. Why do they do this to me? And you get mad and you simply stop buying that energy bar. Okay? 50-cent increase in price makes you switch to something else. Okay? Is that a big response? It's a pretty big response, right? To a 50-cent increase in price. Imagine you're going to buy a car. After hours of negotiation at the dealership, you finally wear them down. It's the end of the month, weather is ugly, there's nobody in the dealership, they have to run up the numbers, they know they have to sell that car to you today. So, you get them, you finally ink that awesome deal. You get your car for thousands under the MSRP, under the sticker price. You feel so good about yourself. You finally sign the paperwork and you tell them, okay, I have to run, I have a class, I'll come tomorrow morning, I'll write you a check, drive my new car home, overnight you will take care of it, refill the tires, whatever, right? Make it prettiful. Next morning, you come, you sit down, you go over the numbers again, and suddenly you see that there's an addendum to your floor mats part of the agreement. And you're like, well, wait a second, those floor mats were supposed to be $144. Now it says $144.50. And they say, oh gosh, yeah, I'm sorry, I forgot to tell you. We just checked the latest pricing. The price went up, it's now $144.50. So you're not getting your car for $18,000, you're getting it for $18,050. Is that gonna be a problem? And you're like, oh, this is outrageous. I'm not buying it. And you leave, you storm out of the dealership. Stop. Okay. So, could a 50-cent increase in the price of an energy bar make you switch to something else? Possibly. Is a 50-cent change in the price of a car gonna make you storm out of dealership and throw a tantrum? Probably not. Why not? It's the same 50 cents, guys.
Because you're already spending a lot of money.
Because it's 50 cents out of a large sum versus 50 cents out of a small sum, right? 50 cents, guys, is a 25% increase in the price of a $2 energy bar, right? Whereas 50 cents is a negligible increase in the price of a car relative to the price of a car. So you see, we have to account for these changes in prices as well as in changes in quantities. as well as for the changes in quantities in terms of, in relative terms, not absolute terms, not in terms of quantities, not in terms of price or dollars, but in relative terms. How do we express relative terms?
Percentage.
Percentage, exactly. So we express these numbers in percentage terms. So let's start with the following example. Let's say the price goes up from $6 to $8, and quantity demanded responds by falling from 4 to 2. So let's first find the percentage change in quantity demanded, and let's find percentage change in price. So, percentage change in quantity demanded. How much did quantity demanded fall in response to the rise in price? From 4 to 2, what's the percentage change?
50%.
50%. How did you find 50%?
2 divided by 4 is, well,
It's not.
1/2 is 50%.
Correct. 4 minus 2 over 4 times 100, right? Correct? Very good. Yes, correct. What am I doing? We're talking about quantity. Now I understand why I was confused. 4 minus 2 over 4 times 100 equals 50%, right? So that's the change in quantity. Of course, it's a change in quantity in response to the price increasing from $6 to $8. What's the relative size of that change?
33%.
It's 33%, correct? How did you find that number?
Divided 6 by a third. $2.
8 minus 6 divided by 6. Sorry, 8 minus 6 divided by 6 times 100 equals 33%. Does that make sense?
So what's the actual, why do you write it like that? What's the 4 minus 2 over 4? Like, what is the actual thing for percentage?
Okay, well, you tell me. Do you remember? It's been a while, huh? What was the last time you calculated percentages?
Like yesterday, math?
Oh, seriously? Oh my goodness. Okay, so what formula did you use?
Just like division. But I'm just asking why you like put 3 numbers instead of just doing like 2 divided by 4. You did like 4 minus 2 over 4.
Okay, let's say you get a raise. You're making $50,000 a year, and you get a raise to $60,000 a year. How much of a raise did you get in dollar terms? $10,000. How much of a raise did you get in percentage terms?
20%.
Hmm?
20%.
How did you get it? How would you do it by dividing 2 numbers? In other words, apply the formula you used yesterday in math.
I don't know. I wasn't trying to make. I was just wondering what.
No,
why you
I
used
mean,
three numbers.
please raise issues. I mean, that's what we're here for.
I mean, I
Absolutely.
just did to do a percentage, you just divide how much you have over.
Okay, so do it. What would you do with those 2 numbers?
When you do 50,000 divided by 60,000.
Okay, what do you get if you divide 50 by 60? You get 5 over 6, which is what? 0.87, something like that. What's next? You multiply it by 100,
yeah.
you get 87. What does that 87 tell you? That you got 87% raise? Is going from $50,000 to $60,000 a year an 87% raise? Definitely not. So what do we do with those numbers? That's the thing. So what you would do in this case is first identify the raise which is 60,000 minus 50,000 in absolute numbers, right? And then you compare it to your starting salary, 50,000. And then you multiply it by 100. That make sense?
Yeah, that's what I was asking.
There you go. So that's what we're doing, guys. So again, you identify the difference, right? 4 minus 2 is the difference, 8 minus 6 is the difference, and then you compare it to the starting value. The difference, 4 minus 2, divided by 4, because that's where you started. That's where the price fell from. With price, it's 8 minus 6, the difference, compared to the starting value. You started at 6 and the price rose from 6. That makes sense? Very good. So, what did we find out by crunching these numbers? We found out that a 33% increase in price resulted in a 50% what? Decrease in quantity demanded. 33% increase in price resulted in 50% decrease in quantity demanded. Would you say that consumers responded elastically or inelastically?
It seems like elastically. I mean, it dropped by 0.5%. Or half.
Good intuition. If a relatively smaller change in price results in a relatively larger consumer response, that's what we mean by elastic response. Okay? That's what we mean by elastic response. Now, generally speaking, to find elasticity, we not only find these two numbers, but we then divide those two numbers. So elasticity is a ratio of these two numbers. Okay? So how much would be 50 divided by 33? Now guys, keep your notes. If you're taking notes, keep your notes, bless you, keep your notes brief. Because we're going to revamp our method substantially in response to something we will find in a few moments, okay? So if you want to keep detailed notes, hold off and keep detailed notes of the final product. That's the one that's going to matter. If you divide 50 divided by 33, what's the number? What's the result? How much is 50 divided by 33?
1.51.
1.51? Thank you very much.
Or 5.2 if you want to round it.
Very good. Thank you. 1.52. So we found that elasticity, which is the ratio of percentage change in quantity divided by percentage change in price, is 1.252. What does it mean? What does that number tell you? What's the interpretation? If you tell someone, well, elasticity is this thing and it's a number, and we found it's 1.252, what does it mean?
I mean, any number over 1 is going to be elastic. Anything under 1 is going to be inelastic.
First of all, that's a definition. You're absolutely right. Just like your intuition was, if consumer response is greater than the underlying price change, it's an elastic response, which is exactly what your colleague says. If elasticity is greater than 1, demand is elastic. If elasticity is less than 1, demand is inelastic. If elasticity is equal to 1, it is unitary elastic, exactly, as a special case. Okay? You're right. Those are definitions. Those are words we use to label demand. Elastic, inelastic, unitary elastic. How about the interpretation? What does that number actually tell you? Does it contain any information above and beyond the fact that the demand is elastic? Yes, guys. Here's what it, yes?
Does it have something to do with the graph? Like, on the graph or
Not necessarily. Let me give you an example. If you bought if you bought 10 pizzas for $80, and then you divide 80 by 10, the result is 8. What did you find?
$8 a pizza.
$8 a pizza. Very good. $8 a pizza. Here we found out that a 33% increase in price results in a 50% drop in quantity. When we divide 50 by 33, what do we find out? Change in quantity per 1% change in price. Okay. Change in quantity corresponding to 1% change in price. In other words, what's the interpretation of this number? If price changed by 1%, quantity demanded would respond by quantity demanded would respond by changing 1.52%. That make sense? So it's basically response in quantity demanded corresponding to a 1% change in price. That make sense?
Is that always gonna be 1%?
The interpretation is always the same, yes.
Okay.
In other words,
That number's
the
gonna
number,
change,
the
but
result you get using the elasticity formula, the number you get, the number representing elasticity, tells you percentage response in quantity to a 1% change in price. That make sense? Yes, go ahead.
Can you repeat you said if it was greater than 1, demand is
Well,
elastic?
if price changes by 1% and consumers respond by more than 1% change in quantity demanded, would you say it's a strong response? Bigger than 1? Absolutely. That's why we call it elastic. If consumers respond by less than 1% change in quantity demanded, it's an elastic response. Okay? We will then order it and give it labels and everything. So we'll get there. But yeah, intuition is good. Okay. So elasticity is found by setting up a ratio of price of percentage change in quantity divided by percentage change in price, and the resulting number tells you percentage change in quantity corresponding to 1% change in price. Let's now repeat the exercise, only this time let's consider the opposite change. Suppose price doesn't rise from 6 to 8, but falls from 8 to 6. And quantity responds by increasing from 2 to 4. Okay? And let's find elasticity. So first of all, what is the percentage change in price? Percentage change in quantity. When quantity rises from 2 to 4, how much of an increase is it?
100%.
Say that?
100%.
100%. How did you get it? What do you do with those two numbers, 2 and 4, to find 100%?
I guess you'd go 4 minus 2 over 2
Times 100.
times 100. Yeah.
Very good. What's the change in price when price falls from 8 to 6?
25%.
25%. How did you find it?
Over 6.
Over
8.
over 8, because you started with 8. So that is 100% increase in quantity demanded corresponding to a 25% change in price, correct? So elasticity is
4.
4. So we found out that consumers change their quantity demanded by 4% to a 1% change in price.
So, I just have a question.
Yes.
Why did you take the 8 minus 6 and divide it by 8? Is that because you just started with 8?
Exactly, because we started with 8. We started with price 8.
8 and then it went down.
Exactly. Look guys, if you're making 100K a year and you get a raise to 200K a year, it is 100% raise, right? But if they cut your pay from 200K to 100K, it is a 50% loss. So 100% gain, 50% loss. Why do we get two different numbers? Because we're using different starting point, right? So getting a 100% raise, getting a $100,000 raise on top of a $100,000 salary makes it a 100% increase. But getting a $100,000 cut from a $200,000 salary makes it a 50% cut, right? So, by applying our formula, we found out that consumers respond to a 1% change in price by changing quantity demanded by 1.52% along this segment of the demand curve. At the same time, we found out that in response to 1% change in price, consumers changed quantity demanded by 4% along that segment of the demand curve. Is it possible to get two different, vastly different results when you're talking about the same thing? Let me give you an example. Let's say you're measuring how tall your 10-year nephew is. So you start measuring from toes to the crown of the head, and you find out the kiddo is 5 foot tall. But when you start the other way around, from head to toes, it's 4 foot tall. Are you happy with that kind of measurement? You're doing something really, really wrong, right? Here, if price goes up, we get one number. When price goes down, we get the other number. And we're still talking about the same demand, and we're talking about the exact same segment along that demand curve. Something's not right. And of course, what's not right is our measurement technique. We use a method of evaluating elasticity that depends on the direction of change, right? And as the direction of the change changes or switches, our result changes. And we don't want that. That's no good. And yes, you already pointed to the source of the confusion. Look, when you compare those formulas up here and down there, you notice that numerators, 4 minus 2, 4 minus 2, numerators in the denominator, 8 minus 6, 8 minus 6 are the same, right? What really makes all the difference are the denominators, 4, 2, 6, 8. So we have a technical glitch. It's nothing more than a technical glitch. How do you suggest we fix it? Well, we could, for example, agree to always use the smaller of the two numbers, right? If it's 8 minus 6, let's use 6 as a base of that percentage calculation, because it's the smaller of the two, 8 minus 6 over 6. Would that fix the problem? Would we get both results the same? Yes or no? No. If this was 6, and if this was 4, Am I gonna get the same number as here?
Yeah.
Absolutely. So you say we should do that? Is that the way we should fix the problem? Well, some people might object, well, why use the smaller of the two? Why not use the larger of the two? Why not use 8 here, 4 here? Well, can you see a way to bypass that kind of discussion? Should we use the smaller number? Should we use the larger number? How about we use both and take their average? Would that work? All right. So how about we use their average? And again, you don't have to keep up with your notes because we're going to simplify this significantly. So let's suppose instead of writing 4 minus 2 over 4 or 4 minus 2 over 2, let's write 4 minus 2 over the average of 4 and 2. But what is the average of 4 and 2? Is it up? 3. How did you get it? Add them up and divide them by 2. So it's 4 plus 2 divided by 2. Correct? Correct? In other words, we're calculating the average. How about instead of using 6 or 8 in the denominator, we use the average of 6 and 8. How do you find the average of 6 and 8?
6 plus 8.
6 plus 8 divided by 2. 6 plus 8 divided by 2. 6 plus 8 divided by 2. Right? Now, we have multiple compounded fractions here. Can you see an instant, simple way to simplify? Look, denominator is 4 plus 2 divided by 2. Here, denominator is 6 plus 8 divided by 2. 2 down here, 2 down here. Is it legit to cancel those 2's out? Absolutely. Same thing here, right? It's the same calculation now. Very good. So, the clean way to express, well, that's number 1, of course. Number 2, we have times 100 times 100. Is it legit to cancel those hundreds? Absolutely. So what's really left in the numerator? 4 minus 2 divided by 4 plus 2. What's left in the denominator? 8 minus 6 over 8 plus 6, we can write. And that is elasticity. In other words, let's write a clean formula down here. What do we have in a numerator? 4 minus 2. What is 4 and 2? What numbers are those? The two quantities, right? So it's quantity 1 minus quantity 2. Okay? The difference between the two quantities. Divided by 4 plus 2. What is 4 plus 2? The two quantities, the sum of the two quantities, correct? And in the denominator, what do we have? 8 minus 6. What is 8 and 6? The two prices. 8 minus 6 is the difference between the two prices. Divided by 8 plus 6. What is 8 plus 6? The sum of those two prices. That makes sense? All right. And that is so-called midpoint formula of elasticity. Midpoint formula of elasticity. So you basically find elasticity by dividing numerator by the denominator. In the numerator, you have the difference between quantities divided by sum of the quantities. In the denominator, you have difference between prices divided by sum of the prices. That's it.
And the 1 stands for the starting price.
Said it very loud.
The 1 stands for the starting value.
The 1 your colleague suggests stands for starting value. In other words, your colleague pointed out that I never told you which one is Q1, which one is Q2. I didn't tell you which one is P1, which one is P2. Is it important?
Yeah.
What if you switch P1 and P2? What will happen to the value of elasticity? How will it change? What about it will change? In other words, what's the difference between taking 8 minus 6 and 6 minus 8?
You get a negative number.
Oh, you get a negative number. Exactly. In other words, depending on how you pick Q1, Q2, P1, P2, you will either get a positive number for elasticity or a negative number for elasticity. Right? This is why elasticity is defined as the absolute value of that number. In other words, it's defined as a positive number. Okay? Given that it's absolute value, does it really matter which one you pick to be Q1, Q2, which one is P1? No. So you literally take a look at difference over sum, difference over sum. Correct? So now knowing what that is, look how you will calculate elasticity. You know, in the numerator you have quantity, in the denominator you have price. So you start with quantity. What's the difference between the two quantities? What's the difference between these two numbers?
2.
2. What's the sum of those two numbers?
6.
6. What's the difference between these two numbers? 2. What's the sum of those two numbers? 14. Congratulations, you got elasticity. That makes sense? That's how you calculate it. 2 divided by 6. The whole thing divided by 2 divided by 14. Okay? And of course, when you crunch numbers, what do you get? It's 14 divided by 6, which is 7 divided by 3, which is 2.33, something like that, right? How did I get 14 divided by 6, guys? Work out the compound fraction.
The 2 cancel, the 2 cancel out.
The 2's cancel out, 14 over 6. Okay, let me show you. E equals 2 over 6 divided by 2 over 14, which is equal to 2 divided by 6 times inverse, 14 over 2. Correct?
Yeah.
These 2's cancel out, and what's left is 14 over 6. That makes sense?
Okay.
Very good. So that's how you calculate elasticity. That makes sense, guys? Good. So, we found out that elasticity of demand along this portion of the demand curve is 14/6, which is 7/3, which is 2.33. Correct? Correct?
Yep.
Very good. Let's try another example, guys. Let's try an example where the two prices are 1 and 3, and corresponding quantities are, if price is 1, quantity demanded corresponding to price 1 would be 9. Quantity demanded corresponding to price 3 would be 7. Okay, so now we have a different segment of the same demand curve. And again, let's apply elasticity formula. What is the elasticity of demand measured along this segment of the demand curve? Let's start with quantities. What's the difference between 7 and 9? 2. What's the sum of 7 and 9? 16. Now let's take prices. What's the difference between 1 and 3? 2. What's the sum of 1 and 3? 4. What is elasticity equal to? 2's cancel out. 16/4 is 7.
Is it 4 or is it 1/4?
It's 1/4, of course.
Yeah. You just flip the denominator.
Of course. 4 divided by 16. Thank you. 4 divided by 16 is 1/4 or 0.25, right? 0.25. So we found out that elasticity along this bottom portion of the demand curve is actually 0.25. What does this tell you guys? First of all, it tells you that elasticity is changing along the demand curve, right? Is it true that elasticity is the same thing as slope of the demand curve? Is it or is it not? Not really. Does the slope of this demand curve change? No, it's constant everywhere. It's a falling 45-degree line, right? It has the same slope everywhere. Does it have the same elasticity everywhere? No, absolutely not. In fact, in this upper portion, elasticity is as high as 2.33. In this lower portion, elasticity is just 0.25. How would you characterize demand whose elasticity is greater than what? Is it elastic or inelastic? It's elastic. So this demand curve is elastic at this segment, but it is inelastic at that segment. Absolutely. Yes.
Does equilibrium equal 1 then? Could you say that?
Unitary.
In other words, is there a segment of this demand curve where elasticity would be, well, unitary elasticity? Sure. Let's try. Let's add price 4 and corresponding quantity 6. Okay? And let's find out what the elasticity would be at this segment. So if we take the two quantities, 4 and 6, What's the difference?
2,
2. What's the sum?
10.
10. Let's take these two prices, 4 and 6. What's the difference? What's the sum? 10.
Yeah.
What's 2 over 10 divided by 2 over 10? 1. Along that segment, elasticity is 1. Demand is unitary elastic. That makes sense? So, demand may have unitary elasticity at one segment. It can be elastic at higher prices than that, and inelastic at lower prices than that. That makes sense? The question is, does every demand curve have the same property? In other words, varying elasticity for different prices. Let me show you another example. Where should we put it? Let's try it here. And this is going to be an exception to the rule, guys. Here, I'm going to introduce an example of non-linear demand. We don't use non-linearities in this class. This is a simple class. Linear demands, linear supplies are easy to use. But let's consider for a second a demand.
Is this going to be a test?
No.
Okay.
Oh, what do you mean? Is this going to be?
The non-linear.
This is going to be a test.
Yeah, we'll take the example later.
No. Let's consider demand where price is equal to 1 over Q. What do you think a shape of a demand like that would be? Well, let's first try. What if quantity is 1? What would the price be? 1. What if the quantity were 2? 0.5. What if the quantity was 0.5? What if the quantity was 0.5? One divided by 0.5, how much is that?
2.
2, exactly. So we have 3 points along that demand curve. Is that demand curve going to be linear?
No.
No, it's definitely not going to be linear. It's going to be a curve. Does that curve remind you of something that you've seen before? Have you ever worked with a function 1 over a variable? What is that? It's a hyperbola, right? In geometry. Very good. So, it's a well-defined simple curve. Let's try and plug in the numbers and see what we get. Let's first try and find elasticity in this segment. Let's start with quantities. What is the difference between 1 and 0.5? 0.5. What's the sum of 1 and 0.5? 1.5. Let's take corresponding prices. What's the difference between 1 and 2? 1. What's the sum of 1 and 2? 3. What is 0.5 over 1.5 divided by 1 over 3 equal to?
1.
Because 0.5 over 1.5 is just 1 over 3, right? So 1 over 3 divided by 1 over 3 is 1. That makes sense? So we found out that elasticity along this segment is equal to 1. In other words, demand, this particular demand curve has unitary elasticity along this segment, correct? Let's now take this bottom segment of the demand curve. Let's take a look at the quantities. What's the difference between the two quantities? Between 1 and 2? 1. What's the sum of 1 and 2? 3. Divided by. Let's take corresponding prices. What's the difference between half and 1? 0.5. What's the sum of half and 1? 1.5. What is that equal to? 1/3 over 1/3, which is 1. So we found out that elasticity is 1. In other words, we found an example of a demand curve that is unitary elastic everywhere. It has a constant elasticity, okay? It's a constant elasticity demand curve. It looks something like this, right? Does it have the same slope everywhere? Definitely not. Its slope ranges from infinity down to 0, right? And yet, it has the same elasticity everywhere. Why am I going into this kind of detail? Your colleague asked, is this going to be on a test? Absolutely not. So why are we talking about it? It's important to reinforce your intuition so that you remember that elasticity and demand are two different things. Okay? Why are we introducing a new measure called elasticity and don't simply rely on slope, something that you're familiar with and you can just look and see? Because economic incidence of policies depends on elasticity. Slope is too simple to capture economic impact of policies. That makes sense? This is why elasticity of demand, elasticity of supply, responsiveness of consumers, responsiveness of producers to changes in prices is absolutely crucial in our estimation of market consequences of various policies. That makes sense? There you go. Generally speaking, from what we've learned, guys, in which markets would you expect the tax to disproportionately hit consumers? In markets with inelastic demand, right? Where demand is inelastic, you impose a tax, or relatively inelastic compared to supply, you would expect the tax hit the consumers, regardless of whether the tax is legally imposed on consumers or producers, right? So that's the purpose, that's the interpretation of elasticity. Very good. What does a typical homework problem look like? Midterm problem, final exam problem? You will solve some simple problems such as price floor or price ceiling. And I ask you to use that same problem to evaluate elasticity of demand and elasticity of supply. How are you going to do it? This is how you're going to do it. Let me clean up.
We're gonna do a break.
Say it again.
We're gonna do a break.
Oh, great idea. Let's take 15-minute break and then we will apply it, okay? Thank you very much.